I'm getting very near to the 500th nightcap. I think it was 497, so there's only 3 more weeks to go, and I'm still not sure what I want to do for the 500th. I've had 1 or 2 suggestions, 1 or 2 of them aren't so pleasant, 1 or 2 are quite interesting, so if anybody's got any ideas or they like what to cover anything I don't know, or just, if you fancy something different, just ask us and I'll see what I can do. This will probably be the final strip down. I'm going to take the crankshaft out. I don't know yet if I'm going to strip all the components off the crank. I want to take it out first. These are what they call modern Whitworth nuts, are the smaller size ones. They changed the size of the nuts during the war years to save metal, and they're the wrong nuts. It should have what I would call big Whitworth nuts on, original size ones. I'll have to try and find some or buy some from somewhere. So if anybody's got a big box of Whitworth nuts they're never going to use again, especially the old ones, I could certainly use them. Now I have removed this main bearing cap before, and this bearing cap has been repaired, modified or bastardised, whatever you want to call it. It's certainly been got at. I've got an ear there. That's not very good. Straight away that needs modifying. The oil hole and the bearing's not quite in line, I'll show that. So we've got an ear stamped on there, and that's where it's been repaired. I'm kind of quite sure what's happened to this. It's had a bush put in there, and a bush put in there. Split bronze bearings, beautiful bearings. And what's happened is there's a hole. Camera can focus on the bastard thing. That's the hole where the oil goes through, and it's actually that bit there. It's lined up on, so that's not sufficient. I want a bigger hole than that, or to line up better. And there's a little thing there. It wants a much bigger groove, or anyway, it's just an oil groove putting in there. It's something we can do, but the bearing is in good condition. We've got a 5 on the back. Is that what I saw and I thought was an ear? No, there's definitely an ear on there. So that bearing goes into that cap. Same with this rearmost main bearing. I mean, these are adjustable in as much as tighten them down. And that pushes on the bearing, and the 2 lock nuts secure it to get the correct amount of clearance. This one has also been repaired or whatever. See where they've been drilled, and they've had bushes put in. There's a mark on that one as well. So hopefully we should be able to lift this out of here. I'm not sure. That's the top part of the bearing, which is in good condition as well. In fact, they haven't been ran, if the truth was known. Right, now we'll just come out of here without taking the standard off, which is this part here. Now the engine I've had running and it ran quite well, and this is all adjustable. So before I take the crank out, or before I take this off, I want to drill this and put some pins in so it goes back in the same place. I'll drill it and ream it and put some 6mm parallel pins in, and it's got to go back together exactly the same way. I looks like I'm going to have to do that now, because I don't think that crank will come out of there. In fact, it won't. No way, it's a physical impossibility. So we'll leave that in there, get this on the milling machine so we can drill 2 holes in there just to put some pins in. I may have to make a long tapered along adapter for a drill. Use a 5.9mm drill and then a 6mm reamer. And this one stays big washers, putting on when it goes back together. Oh, I've put the main bearing caps on loose just to hold the crank in place while I remove this part. You can see nothing's been tightened, it's been sort of, I don't know, the mystery deepened really, and that's quite badly pitted, but that's a really nice item that'll polish up lovely. And I could make another one out of stainless, but I'm just going to clean that up as best I can, because it is old and I want to leave it looking old. I don't want to completely, I want to restore it, but I'll leave it the way it was built in the first place. A sympathetic restore, I suppose. You see the bottom of the base plate, quite a sturdy casting. Decent enough bit of kit. Right. So I've got a 5mm dowels, I've got a 4.8mm drill. I'll have to put an extension piece on so I can get in it to drill it. And we'll do that now. We'll make an extension. And I've also got a suitable 5mm reamer. These are the little 5mm dowel pins. We've got holes in so you can, they'll knock in just below the surface and you can pull them out. Nobody will know they're there. And if they had these when they built the engine, I'm sure they would have used them. I found a little Jacob's drill chuck on a mandrel that gives us enough clearance in here, but unfortunately I've got problems up here hitting things, so I still need to make a longer drill. But I'm just going to find out what that thread is and make a longer mandrel for that. And then we're going to be, because that has got clearance in there, it means it's got to, we've still got clearance issues up here. I think that would actually go, I think we'd get it just, I could make a guide and drill it freehand, but I'd rather not do that. I'd rather persevere and try and drill it with a machine. Make sure that's hitting there, but it would, if that was longer, it would definitely have enough clearance. Or would it? Yeah, it would. I've also got a limited bit of travel, which there's enough travel there. I'll find out what thread that is and see if we can make a little adapter. Right, that's 3/8 ONF, definitely. I've got a 3/8 ONF die, so I can make a little adapter to screw into there, cut it to the right length, and then we've got an extension for different drills for different applications. And I can also put the reamer in here as well, so that should be good for that. I may take that out and put a collet chuck in. I just put it in a plain collet in there. I got the length right, but I've got that much travel, which is more than enough. Does away with that chuck, and then put it straight into an R8 collet into there. And it means this bit won't be in the way. Bit of suitable steel rod here. This is what was left off the brakes I did on that Sentinel steam wagon all the world. That's running reasonably true. We'll chop the end off that and put some threads onto it. Sure it'll be a good enough bit of material for what it's got to do. Idea what grade of steel it is. It's just something from under the bench that was worth keeping. It's just made steel, it's machined quite nicely. Perfectly good for what it's got to do. Centre height. It was. Yeah, definitely made of steel, very teary. But that tip in there is not the best neither. It's the size we're heading for. We've just about got it. Clean that shite off there and that'll tighten on that face. It'll be reasonably true. That's the drill extension, or the drill trick extension we've just made, and that's an R8, standard R8 collet, which goes up into there, drawbar screws into it, and that means things are really close to the spindle. You haven't got the overhang of a chuck. That goes into there, and hopefully we'll have enough height on there to be able to do the job we need to do. It is adjustable in that collet. I can drop it an inch or so up or down. I need to make a new spanner for this. Right, so the drill goes into there. I haven't got a chuck key for this, unfortunately, and that's going to be going into there. Which one am I going to do, I could do that one. And there's more room on this side. It's still going to be tight, this, no matter how I do it, because that bastard thing's hitting the frame. So really, we've made that and we've gained nothing, nothing at all. Well, we've made an adapter that we can't use, I suppose, for certain things, but it won't work on this particular application because that's hitting the chuck. Like I say, it won't work because that chuck hits there, so I'll have to make another piece of shaft and just put the drill straight in the end of it. I can probably use this one, turn it around and put a slavery bastard thing. Right, so it's back to the drawing board as far as this particular job goes. Right, I've got another bit of the same material. That drill's going to fit in there like that. I could raise that into there, but then the drill will be scrapped, so I'm just going to drill it and put a little rub screw in, and I'll probably do the other side exactly the same so I can fit the reamer into the other end. That's a 4.9mm drill, and that's going to be the reamer. Now that end of the reamer measures at 5mm, so if I put it through there, that should be a nice fit in that hole, hopefully. So that'll be great with just a little rub screw in there, and I've got a double-ended tool, one end for the drill and one end for the reamer. Right, so that's the setup I've ended up with to put the pilot drill in, the 4.9mm drill. Nice soft cast iron, it's drilling really well. I'll go all the way through, and I have to now knock the pin right through. Right, let's go through. I've put the reamer through the hole. Unfortunately, I forgot to start the camera, but it was exactly the same as drilling the hole, except I used a lot slower speed, and that's a little parallel double pin, or a little parallel pin that goes in there. It's going right through into the base, so now when I come to put it back together, that'll make sure it's located. There's a little threaded hole in there, so I can pull it out with a little metric bolt. Once again, just time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please click the button, it does make a big difference. Anyway, thanks for watching.